Hello class. So me and my partner did the SEP video on practice 4, which is analyzing and interpreting data. And we decided to split our videos by age groups. The one group is K through 5 and the other is grades 6 through 12. And the reason for that is because we decided that there's more differences based on the age groups than there are from science and engineering. Science and engineering analysis is pretty similar, even though there are some differences, which I'll get to later. So basically what data analysis is and interpretation is taking the raw data and trying to make sense out of it. It is trying to understand what that data means. And based on the level of the student, there's different complexities of analysis that they need to do. Something like just finding patterns, finding causation versus correlation, or just any relationship there is. But in the end result of the whole program K through 12, they should be able to explain what looking at the results, they should make certain conclusions out of them. So looking at grades 6 through 8, which is middle school, the level of analysis that these kids should be able to do is, that is when they get to more familiar with quantitative analysis compared to qualitative. That is when they start using the numbers to try to see what the data means. And that is also when statistical techniques come into play. So the statistics that these children would work with is something like finding the mean, the mode, variability, or the median. And another level of analysis that they do is using graphical displays. So something like maps, charts, or graphs, they should be able to look at it and understand what it means. And not only look, but sometimes that's when they also start experimenting with themselves with these, trying to make a chart, trying to make a table, and based on the results that they got. So that is also, middle school is also the level that students start to distinguish between what is causation and what is correlation and what's the difference, and looking at the data to see if it is, which one it is. Another concept that students learn is the limitations of data analysis, like what can go wrong, the measurement error, and the technologies or tools used. Students understand that the data that the data they're working with can be flawed, and they should be looking at it as a way of just measuring what they have right now, but not necessarily as the total truth. So the difference between the science and the engineering practice of data analysis is that in engineering, the students are not more likely, but look more into the evidence for a certain design. They take what they have, or the results that they have is basically on how good something is being made. They make something and they analyze the data, doing the tests on that certain model to find errors or to find how well it is made. While in the scientific world, the data analysis is more done to see how well, or not even how well, but what the data means. Science says what the data means, while engineering is trying to explain how well how well something is made. So also, so going now on to high school, the difference from high school and middle school is that the statistical analysis gets more complex. That's when students start using different tools or technologies and models to explain what the results mean, and some of them are computational or mathematical and more complex than in middle school. Also, the statistical analysis gets more complicated in the way that they're not just looking at the mean, the mode, or the median. And that is the level where students start looking at the slopes, at the intercepts, and the correlation coefficients. So the level of math or like actual statistics gets higher and more complex. And just as in middle school, there's higher levels of limitations that students need to look at, and also that is when students start looking at different data that they get and comparing different data sets. So if they do an experiment, they might look at previous experiments done and trying to compare the results and what they mean, or if they're similar or if they're not. And that's the end of my discussion. Thanks.